So here's a better illustration of the superantigen response. So this is the conventional antigen response, is that you get a specific reactive B cell that forms. Here you have non-specific reactive B cells. So basically these have no idea what's going on, what they should be forming and responding to. All they know is that they're all here and they feel like they should do something. Now the other way that superantigens work is that they bind to a type of troll-like receptor, if I'm not mistaken, and then cause a hyperproliferate or superclonal expansion. Basically, these immune cells go, again, like I said before, they grow like crazy and they cause a whole lot of immunological reactions. Some of them die, which also causes some inflammation if it's in excess, and then not a whole lot is known about what is going on to how it's regulating itself. How do these cells with the superclonal expansion and activation, how are they making sure that this is not over and above and that they're not making excessive ones that they shouldn't be? Now you would think that maybe the dendritic cell could also play a role here, but remember that this superantigen is starting the process before most of the dendritic activity can actually occur correctly. Because the lymphocyte is where the best sort of understanding of what the body needs to respond to is, but it can also occur in other areas. Here's another great example of how this works. So this is again a troll-like receptor sort of response, or troll-like receptor, and this is what this is a lymphocyte that needs to understand what it should be responding to. So you have this guy who's thrown up his troll-like receptor. It's not a troll-like receptor. It's basically something that the troll-like receptor can actually recognize. And so it's throwing up this recognition protein, I should say. But what's happening is that the superantigen, in so many words, is actually binding to that receptor and then inhibiting that appropriate protein binding, and therefore causing this excessive response. So typically what happens is that when these two can just sort of match up, when this nodule connects with this nodule and this one connects with this one, they get to talk, they chat it up, they go, oh, that's what I need to talk to, that's what I need to form, okay. But when it does that, it's kind of guessing. So this guy knows he just needs to go in super reaction and tries to go and search via intensive immunological reaction of this appropriate receptor within its genetic understanding. But what happens is when you have this blocking, that communication never doesn't occur, and now it's looking for nothing. Basically, this cell is expanding like crazy and has nothing to attach to, has nothing to recognize, and therefore this superantigen is basically causing just hyperproliferation of these T cells, and again that causes intensive immunological reactions to something like a protein formed by P. acne, and therefore you would think that, okay, if acne is an inflammatory, if P. acne is the source of my acne, I just need to kill off all of the bacteria and then I'll be fine. So I'll just wait out this intensive immunological reaction. But this superantigen production is how the P. acne sort of avoids the immune system while allowing it to grow even more rapidly by causing a non-specific immunological response. It's a really ingenious mechanism that's very sinister as well. So I've talked a lot about antibodies, but we really haven't gotten into what antibodies are, or what they look like. Well, or what they do, for instance. So there's a high... These antibodies are generally very, very specific. There could be some element of cross-reactivity, as which occurs here, meaning that an antibody could respond to two different kinds of epitopes because they are so similar. But so maybe that's why you react to all nuts, all tree nuts. But the other important thing to understand too is that sometimes what the antibody is responding to is a common protein within all of those tree nuts, or common epitope within all those tree nuts. So it could be that there's a cross-reactivity, but more likely it's just that there's a similar protein within all of those food components. And basically, another thing that's very important is with regard to the strength of the antibody response. So here's an interesting illustration of basically two ways this occurs. This is a direct, strong affinity, basically a very strong reactivity connection with this protein. Here you can see these are kind of weaker connections, but because there's so many, you get an even stronger response of the immune system, which is a very interesting sort of way that the body sort of enhances reactions. So IgA, this is what's decreased with isotretinoin, and interestingly enough, it's found in mucus, saliva, tears, breast milk, and is important for protecting against pathogens. So this basically forms a layer around which the immune system doesn't respond. So IgA is very important within the gastrointestinal tract so that things don't go through into the bloodstream and also don't react on top of the cells that line the gastrointestinal tract, because when they're covered by this IgA response, they're rendered basically inactive, and therefore the body is only recognizing this IgA and doesn't necessarily need to react extensively to it. This could be the reason why individuals who are drinking milk, sometimes when they're drinking a lot of milk, they have a lot of phlegm. Well, if you look, I bet you not, because this has been looked at once before, but they didn't do an appropriate job of finding which protein they should be looking at when evaluating the quantity of mucus. But if you look for an IgA response to milk proteins, I bet you'll find this elevated. So if you have a lot of mucus production, this could be your body trying to actually not react to the milk, even though but it also is a great indication that there could be some leakiness in this, in that the body is still responding to the milk protein, but because of this IgA, you're responding a little bit less than you otherwise would. So this is one thing that people have now are like, well, then if isotretinoin, Accutane, reduces IgA, dries you out and everything, does that predispose you to get allergies? And or irritable bowel syndrome? I'd like to say yes. I don't think the research is out significantly enough for me to say that, but I certainly think that it's under-researched, and as such, I feel more safe saying yes than I do say feeling no. So now the other things is that we also have IgD, which is another cell that's important for mast cell regulation. IgE, this is a big one. This is the one everyone likes to talk about. This is the one that's being tested for typically when you're looking for, are you reactive to wheat or are you reactive to soy protein? They're looking to see if you are immediately reactive, you're IgE related reactive to a protein. This is why your throat closes up immediately. This is why a stream of other issues occur, such as extreme diarrhea or vomiting upon ingestion. It was probably formed so that we can fight off parasites, which is a very interesting reaction. So this is the one that isn't talked about enough, and this is the one that we should really be looking at when trying to evaluate whether or not someone could be intolerant to something. Allergic responses are generally life-threatening and extremely disruptive to life. IgG could be the same, but because there's this delayed onset allergy response, I would still call it allergy. Some people would call it intolerance. I don't think it's an intolerance. I think it's an allergy because you're still responding with an antibody response. So you could be reacting with this IgG, which isn't being tested against. Now, I told you that IgG4 is good, but that doesn't necessarily mean that is in all cases, and also there's other different kinds of IgG. It's complicated. I'm sorry it is, but I didn't make the body. I just am trying to analyze it for your sake. And again, here's the IgM, may be attached to the surface of B cells and excreted in the blood, responsible for early stages of immunity. So when we're born, we don't have all of these antibodies responses. So basically, we don't have the IgA, we don't have the IgE when we're a baby. Well, the only thing we really have initially is IgM cells. So we're actually relying on our mother to give us the appropriate antibodies so that we can not have an allergenic response to certain things. Or, in some instances, we actually may inherit via not necessarily the DNA, but actually by the milk exposure from our mother. So this gets in the complex thing of, is breastfeeding protective against allergies or not protective? Well, I think it's protective as long as the mother doesn't have an allergy response already. So it's complicated again, but basically this could be a very fundamental way that we can potentially help people grow up with less allergies, is trying to develop it's very hard to develop appropriate antibodies, but develop maybe a breast milk analog, a perfect breast milk analog that actually can modulate the immune system appropriately, or just like you would screen for donors for serum, you could screen for people, blood serum that is. You could screen people for the perfect non-reactive breast milk, and therefore you could give someone, if you typically have this intensive nut allergy that you don't want to give to your kid, or if you have this intensive milk allergy that you don't want to give your kid, then you could look for possibly a breast milk donor that doesn't have an allergy response. Blocking antibodies could be a saving grace to allergy development. So as the best example we can give, or I can give, is that with the development of peanuts allergy, you can actually treat it with microdoses of peanut. Now these microdoses of peanut protein cause an allergic reaction in a sense, but it's so mild that the body can actually adapt to it. It adapts to it by creating a secondary antibody, an antibody called a blocking antibody, and that's an IgG4 antibody, as specific to peanuts so far as I know. Now, this blocking antibody actually binds to the antigen but doesn't react. And in fact, there's also inhibitory sites on cells from the antibody that it can block to. So not only can you get a blockage of this from causing the development of an allergic response, but also can actually have a suppressatory effect. Now, basically what this means is you eat peanuts, you have your B cells send out all their antibodies that go on and bind to the antigen and try and get the mast cells to secrete histamine, and you would basically start developing a reaction, either be it that you have an anaphylactic response where you cannot breathe, or another response that would be similar to you breaking out. Now, with the blocking antibody, during this response, not only do you get these antagonistic antibodies develop, but you also have these blocking antibodies develop. So they actually sort of compete. And when the cells are, or when you have a small microdoses of protein, you can actually have the blocking antibodies almost outcompete with the antagonistic antibodies for this antigen material. Now, when that occurs, you more or less negate the reaction that occurs as a result of intaking that protein. So you almost have an internal competition over this antibody or antigen about what to do with it. So, and the most amazing thing is that over time, you actually stop producing IgG4. You stop producing this blocking antibody, and you stop developing the antibody antagonistic antibodies altogether. So it doesn't necessarily mean that you could just go from eating no peanuts and having allergic reactions to eating, a whole jar of peanut butter, but it may create, a grounds for you being able to consume small doses of peanut butter and not have a reaction. So, but then again, it still sheds light on the possibility that you could go from having an allergic reaction to the tiniest doses to being able to eat a whole jar of peanut butter. And this would mean wonders for people who have acne and they frequently have, unexplained blisters or papules from basically eating a whole number of foods thanks to cross-reactivity. I mean, if you can reincorporate whole food groups because of the development of this blocking antigen, you would create a much better life for an individual and someone who can actually live their life more to the fullest without having to worry about their face. Now, something else that kind of goes along this lines is IgA. Now, IgA antibodies actually, as you saw, they're the mucus aspect, so they block and line the gut. So it's almost like a blocking antigen, but it's in more of a physical way than it is in the sense of the this sort of competitive way. It actually physically blocks out the ability for the protein to leach in and for it to interact with more reactive immune cells. So, I mean, really, and this would be tremendous if we can find a way for it to work with superantigens as well. So how could a blocking antibody work with the super antigen? I mean, the thing is because you have many sites which antibodies can bind to, you may have some difficulty there. And keep in mind things like certain. This is how certain toxic compounds are disposed of. The antibody binds around the toxic compound, renders it inert, and then you can basically dispose of it, opposed to that toxin being able to bind to a cell and cause something like apoptosis. Now it just binds the antibody binds to the toxin and doesn't allow it to bind to the apotic site. So again, antibodies are very useful. I think we're going to be talking a little bit more about them, and hopefully much more in the future, and its prospect for defeating a number of diseases, including acne.
So to be honest, I'm kind of tired, just like you, of continuing to talk about stuff that isn't directly relevant to the to acne. But T regulatory cells are also another fundamental target for immunological protection. I told you IG4 could protect against allergy development with low doses. Well, T regulatory cells basically have also this action of calming down the immune system. Oh, it regulates it. Doesn't necessarily. They used to be called suppressor T cells. Basically, it uses all of the immune reactions that are many of the immune molecules like IL-1 and IL-6 and IL-10 and 17 to understand if I should calm the system down or try and ask the cells to keep upregulating these inflammatory components. And here we see that with the cell-cell contact, when it's connecting, asking the cell, it's sending these cytokines, which are IL-4, IL-10, and I forget actually what that acronym is, and suppresses the development of an antigen recognizing protein to ask another effector T cell, basically another immune cell, to activate, to react. So by blocking this one, you're blocking this one, and then this also directly can block this as well. So basically T regulatory cells have an ability to tell everyone to chill the hell out, or basically get them to hey, we need defense. we're falling apart here. Here's another illustration of how that occurs. Remember, I'm not an expert, but I also think that someone who is can also have a much greater understanding and importance, and these illustrations may have more relevance to some people than others, depending upon how much you know about the body.
So here we go again with allergy development. And this is going to be a sort of reinforcement of what we discussed before. I want to stress why I'm talking about allergy development so intensively is because these are the strongest responses that we have, and have such diversity in their presentation of what they could be, from anything from eczema to acne to headaches to throwing up, that it's really important for us to understand. A lot of the times people will ask, like, sure, I'm allergic to something, but why am I allergic, or why is it like presenting like this and not like that? And it's difficult for people to say, and because they have to go about trying to explain the system, and it is highly complex, needless to say. But by giving you this information, at least at a baseline level, you'll be able to better
understand and effectively research what you think are the most appropriate ways to monitor an allergic reaction, and how you think you might be able to want to cure or invest money in research development into these. I'm not saying that you're going to go, start your own laboratory, but you may, rather than just fund an organization which allocates the money that you want to maybe say curing acne, you want to say you want to research you want to fund the researchers that are doing exactly what you think are the most appropriate measurements to treating the condition. So that's just why I'm focusing on this so much. Now, so here we have the bacteria, and this could also be any true antigen, really, any antigen, such as something from a food. So it could be that this is, say, the spaghetti meal that you just ate. It really doesn't differ too highly, but as you can see that there's proteins inside, let's say, meat. Why doesn't everyone react to those proteins inside meat? There's a whole lot of proteins. You would think the more protein, the larger risk of becoming allergic to that. Yet you don't really see that many people getting having severe allergic reactions, anaphylactic reactions to red meat, surprisingly. So that's why you have to work within the context of the system, work within that whole the major histoimmune complex and that sort of regulatory T cells and those antigens and everything. So, sorry. To walk you through this illustration, there's a couple different ways to which antigens are captured. One is through endocytosis, basically meaning that these cells, these M cells, help suck up the antigen, in this case a bacteria, and show it to your antigen presenting cell. Now, such as the dendritic cell here. Now the other way is, this isn't the correct illustration now, it's actually a different cell that comes in here. I've told you this before, a different cell that comes in here and actually shows what dendritic cell this should be, or presents what it should be, the antigen presenting. Now that, because this is two different pathways, but we'll walk you through both. So basically, at the end of the day, both of these are walking through this general pathway, meaning you get this antigen presentation, and then you get the proliferation phase. As we can see, these guys are talking. This dendritic cell basically becomes activated, and then this activation then translates into more T cells and effector T cell development, B cells, and all that. So then these are all going through this, and then you get the selection phase, and it seems to, I think what this illustration is saying is it's going more towards a IgA mediated development. Remember, those are sort of remissive antibodies, meaning that they don't allow excessive penetration of these antigens. So now these B cells differentiate, meaning so increase differentiation and become different kinds of B cells. So one thing I haven't talked about before is, let's say you are maybe allergic to milk, right? Well, I'm allergic to milk, say. I believe I am, but I'm allergic to milk, and I really didn't get much acne on my back. The most primary area I got my acne is my face. Why do some people break out in their face more than they break out in their back? And one of these mechanisms is what's called the homing system. Now, this basically means that cells are directed, immune cells are directed towards a specific area. And it could be that you have just, had some physical trauma to the area. So let's say maybe you're a cheerleader or something, and then you're on your back. Oh, that's terrible. You're a football player and you're wearing a lot of shoulder pads all the time. That abrasiveness starts an inflammatory response, and that opens up the presentation for these immune cells to go there. It basically says it's you have the allergic response, and it's basically a shotgun trying to run out of the barrel. As soon as you start some abrasive action, that's basically the trigger that shoots the immune cells out, and that's what they go towards. And then once they're there, there's the memory T cells, which you've probably heard. Once you've had an allergic response, you're more likely to have it. Once you've had an antigen exposure, it takes a second to develop the antibodies. Not a second, but it takes a second exposure to develop the antibodies, and then you have this strong immune response. And why they might be in one area more than other depends upon a variety of factors, but one of which is this previous trauma, along with, it seems that certain proteins have a higher likelihood than to be responded to in a specific way than others. Meaning that you may be allergic to milk, but again, like I said, you're not allergic to milk, you're allergic to a certain kind of protein. You may be allergic to a different kind of protein than your friend is, who has a reaction on his face. So, because of what that protein is that you're reacting to, you may have a difference. And so, it could be an inclination to what you need to treat, being the where you're presenting your allergenic response, provided it is an allergenic response, could be a way of appropriately treating the individual, such as you. So here we have some other developments. I apologize, I'm not 100% sure what this is. And so then you get some increased crazy reactions that are occurring. And as I said, these are IgAs. See how they basically swallow up these antigens, such as the bacteria, and doesn't allow them to diffuse through the membrane, and limits their allergenic response. So that's basically what I wanted to talk about again. Again, here's another way this gets translated into an allergenic response. As you can see, there's multiple pathways of allergy development, and that's why it's difficult to target one versus another, because thankfully the body has the ability to compensate for any sort of specific monogenic deficiency, meaning if there was one gene that was screwed up or one thing that was screwed up, you can still kind of get by on at least regarding the immune system. Now, getting by is certainly not thriving. You may die much more likely than somebody else who doesn't have one of these deficiencies or changes, but at the very least you might have the chance to make a baby. So here's one thing that I thought was really exciting, and this is inflammasomes. These are, remember we're talking about IL-1, IL-6. Well, where are all these things? How are these things manufactured? How do they develop? Well, they develop through these inflammasomes. I'm not making these names up. This is actually what they're called. This is a complex illustration of them, which I'm not going to get into, obviously, because it's just a headache and a half. But one interesting thing that I'll showcase is autophagy. This is basically something that happens when you don't eat. When you don't eat, the body sort of goes into this catabolic activity. It sort of eats itself, and that action seems to have a suppression effect on certain inflammasomes. such as this one and this one. Now, the other thing which is very interesting is the fact that this inflammasomes develop cytokines, meaning without these inflammasomes you're really not going to get, which are present in all cells as far as I know, you're really not going to get a development of something like IL-1 alpha. This has been shown to be a critical component of both all of these diseases here and acne. This seems to be one of the first things that occur in acne development, which I believe I've touched on before. This is another gene here that's very important for lipid development, meaning something like sebum secretions, that oil that comes from your face. This is a gene that's really important for that. So as you can see, there's a high degree of interest in utilizing these inflammasomes to suppress the immune response so that we don't overexcite it using acne. People who have a lot of acne on their face are very inflamed. By suppressing it via maybe a sort of inflammasome inhibitor, we could potentially get an improvement in the condition. It's been looked at just briefly as of 2014, if this can be effectively utilized, and it's also being looked at for all those other diseases as you saw below, but it's not something that it's in its infancy, and it will be a long time, I believe, before we see this come to market. But it's interesting to note, and it gives you an enhanced idea of what is going on. Another thing that's really important to draw your eyes to is this UVB. So this UVB, which is basically UVA rays, UVB rays. Think of this as your skin cell, and if your skin cell is getting UVB rays, you get inflammasome development. Now, does this mean that quote-unquote autophagy so not eating would suppress the inflammasome so you wouldn't get a sunburn, or that you wouldn't get some sort of negative reaction to the UV rays? No, that doesn't mean that, but it does mean, because these have different strengths in all their suppression and activation, which is not properly illustrated here. But it'd be an interesting idea to check out if people who are lacking food are less likely to have a sunburn. But regardless, that's just one way that you could look at this to give it an increased affection to what I'm trying to illustrate here. So I think we've talked a lot about basically acne's development from an allergy perspective, but now we're going to be getting into the acne and also the immediate immunological response of the body, which is via troll-like receptors. Accutane seems to be able to work most predominantly on troll-like receptor 2 and troll-like receptor 4. Basically what it does is it reduces the number of troll-like receptors on keratinocytes, like skin cells, and immunological cells, and because it can't interact with the lipopolysaccharides and the bacterial lipoproteins, you basically don't get the reaction, or specifically you don't get the reaction as intensively. So this is how the body, again, recognizes a pathogen. So you have this bacteria sitting here, and then it ends up
attaching onto the toll-like receptors, because the skin cells are like, oh, I gotta fight the bad bacteria, and basically it attaches to the bacteria, and then you have this intensive inflammatory response. So basically, if you cut off these, specifically toll-like receptor 2, cut off that response, then basically you don't get the inflammation that the bacteria is causing. Now, there's other routes of which P. acne can cause inflammation, but this is without a doubt the most dominant way a bacteria can cause, or at least the most common way a bacteria can cause acne. So again, blocking this with Accutane is a very effective method, and also trying to manage this and comprehending this aspect of immune recognition of P. acne can really help the development of future medications and your understanding of how P. acne can cause acne. Here we are. Okay. Now we're getting to some more relevant topics like testosterone. So, pimple life cycle meets wound healing, meaning I said it before, or I believe I said it before, where I think that acne is strongly associated, and it has many pathways that are coordinated with healing. I mean, if you look at just the development, we say that there's dead skin cells inside the inside the pore. The first thing is that they're not dead; they're very immunologically active, and they're hyper differentiating, hyper proliferating. It's healing. When we cut ourselves, if we didn't have a rapid division of cells, that spot of healing would take forever to heal. If we just right now, a lot of the growth that's occurring is very very slow on our skin relative to when we're actually injured. When we're injured, get a little scratch or something, those cells know to, okay, let's speed up the healing process. Let's speed up these this development of the skin, and that's kind of what's going on with inside the sebaceous gland. Is that the skin is almost trying to heal up your pore. It is literally trying to clog your pore in this, because it sort of thinks that it needs to, meaning that it needs to heal the pore, and that effectively creates an issue where you're clogging it and obviously creating the microcomedone and then the pimple or cyst. So how inflammation occurs is first that you have this homeostatic state. You have a state where everything is normal and everything is imbalanced. You're neither inflamed nor not completely inflamed, because if you had no immunological response to anything, then any bacteria or any issue could kill you pretty quickly. So basically you're at a state of perfection. Let's say this is when you were 9 years old or something and didn't have any acne. Then you have the initiation of inflammation, which could be from toll-like receptors, which initiates IL-1 development. So this IL-1 is like the first thing that occurs. Now, when that happens, some of these things are sort of co-occurring. When you have this inflammation, you start getting some proliferation, remodeling, and stuff. But some of these things occur a little bit before others. Now, with this inflammation, you're getting a vasoconstriction and then dilation. So basically, you have a tube, which is your capillary, right? Let's say this is running through your face, and you scratch it. When you scratch that, those capillaries are going to close up really quick,
because the first thing that they want to do is that they don't want to lose a bunch of blood. So you have this restriction, and what this also starts with the inflammatory response, which basically gets these adhesion molecules, which can basically stick to those that capillary, and as that capillary then gets more and more cells stuck to it, it's going to start the dilation phase. And with this dilation phase, basically an opening up of the capillary, you're going to really start the healing process, meaning that you're going to get intensive proliferation of your skin cells, and then you're also going to get remodeling, meaning you could get a scar development or you could not get a scar development. This is kind of dependent upon things like MMP and its inhibitor, TIMP. So there's also something which we've touched on a little bit, which is not only are there cells, there's proteins which are integrated into this whole mess as well, such as keratin. In this case, keratin 17, also something that's very important for scar development. So all these proteins and everything are mixing around. Some of them are more or less signaling proteins. Some of them are actual structural development proteins, but they are important for the healing process. So here this is basically illustrating, this is going back into scar development, and when you're ever talking about scar development, you're actually talking about fibroblasts. These are cells that basically shoot out a bunch of, I would call it structural material. So basically, anyone who knows about construction, they know that things are made out of concrete, but they also need sort of rebar, strong steel rods that run along and make up the whole structure of the building. Basically, think of this keratin and these fibroblasts as think of the fibroblasts as rebar producers, and think of keratin as the rebar. So as you get more and more quote-unquote rebarb, you're going to get a sort of stronger structure, but it's not going to be as effective in its functionality if it doesn't have enough of, I guess you would call, the concrete, that being the cells in there. So if you have an improper or overproduction of rebarb, you're not going to actually get the structure that you need to. And one of the things that basically tells fibroblasts to shoot up as much rebarb as you can is keratin. I'll try and stop with the analogies, I'm sorry. Is testosterone. So testosterone comes from the blood, interacts with these fibroblasts, is converted to dihydrotestosterone, which is a very active form of testosterone, attaches to the androgen receptor, which basically causes genetic expression. Then this goes to these genetic factors go into the keratinocyte and the sebaceous sites. Sebaceous sites, again, are the cells that secrete sebum, the oil, and then this effectively gets activated, as you see, and alters the development of their lineage. So basically, it makes them proliferate, and it makes them clog up your pore and or makes a scar, which is something that we obviously don't want. To properly re-establish this, again, I know I keep trying to reinstill these ideas into you and give you a myriad of directions, because I think there's a lot of people coming from a lot of different backgrounds, and if you give enough examples, you can touch on more people. It's harder to hear or to listen to because you have to listen to everyone else's thoughts and directions on the information, and some things may not be effective ways of illustrating or translating information to one person than it is to another. But now I'm rambling. Okay, so eyebrow tweezers. Why is that in this slide? Okay, so what I found to be one of the most effective ways to predict a pimple development is to tweeze eyebrows. If you, let's say in the center of right where your unibrow is developing, if you have like oily skin and it's a sort of acne prone area, if you tweeze that, you're going to get a pimple almost in the exact, if not in the exact same location of where you ripped out the hair. Now this is unprecedented in my eyes. You could scratch your face, you could do all sorts of different things, but you're never going to actually get 100% accuracy in your predicted development of the lesion. Here, you can almost pinpoint exactly where that pimple development is. So this really points to the idea that once you pull that hair, that now you've initiated a healing response. And because you've initiated that healing response, you're getting this hyperproliferation of the keratinocytes. You're getting this overhealing response. You're getting this excited response that develops into a pimple rather than a new hair follicle or anything of that nature. So it's really important if you need something that really solidifies this idea, that go ahead, try and tweeze your eyebrows, and maybe it won't be the largest pimple you've ever seen in your life, but you'll get a pimple, especially if you pull more than like 10 hairs, in my opinion. So the other thing which is really interesting is if you look at burn victims, they actually have an increased need for nutrient intake, certain nutrients such as vitamin C and protein. If you think about acne as being maybe a issue, either not healing enough or too much healing, then you may think these individuals need to have a tapered nutritional plan that works within their condition. Let's say if someone gets a lot of blackheads, they're probably nutrient deficient, whereas someone who's getting a lot of pimples, whiteheads, or cysts may have too much nutrition. So it doesn't work like that 100% of the time, but that's one of the perspectives that you can take. It has a lesser degree of importance than the other things I've talked about, like polycystic ovarian syndrome, which I just barely touched on, but we'll go back into that, and allergy development and insulin. But that's one of the ways you can sort of approach and look at this problem, and maybe that's one of the ways that really resonates with you. So a lot of people like to know, when is this pimple going to be gone? I understand that I have a pimple, I understand it's there, but I want to get rid of it, and I want to know when I get rid of it. If people knew the date that they were going to have clear skin, if they knew the exact date, that would give them a world of peace. They wouldn't be as stressed out to the condition if they knew when it was gonna end. And the unfortunate thing is, because each individual has so much variability, and because we really do have so much control over the condition, that it varies greatly. But one thing I can say is that
if you really don't treat a pimple at all, this being a pustule, in about 14 days it should be gone. That specific one. If you have multiple pimples, obviously they're not all going to go at the same time. But if you don't pop it, if you don't do anything, within 14 days it should go away by itself. Blackheads can take months, unfortunately. And it's because they're sort of not active. They don't have the as intensive immune response as pustules. And these sort of so you have this decreased plasticity and a decreased excitement to the area. Now cysts are actually a little bit contrary to this idea. Cysts are typically, I would say, they clear up before most blackheads, not all, most blackheads. I haven't gotten these, and this is just my opinion as it stands right now. I'd like to get your opinions as well. But cysts, they remit, they go away a little bit before a blackhead does, but a lot longer before than a pustule. So it's sort of right in between. Now this is because you have this super intensive immunological response that takes a very long time to stop and allow the body to realize that it's going in the wrong direction, and when it finally does, it has to back off that, and that takes a very long time. The other thing is really important to remember is that the treatments that we use, whether that be benzoyl peroxide, salicylic acid, adapalene, or just dietary interventions, are going to have a huge ability to shrink the durations at which these stay on your face, whether that be a blackhead or whether that be a pustule or a cyst. Cysts, I mean, it's obvious to many that if you go and get something like a laser treatment or your esthetician pops your lesion, that it goes away. I mean, it goes away that second. So we have, it's not really necessarily the best way to do it, in my opinion, but we have some spectacular treatment protocols that, or not, I shouldn't say spectacular. We have good treatment protocols which can quickly change the conditions that you're in. I mean, if you're really stressing and you have a big cyst on your face, and like a week or two you're going to go to prom, you could get a cortisol injection and it'll go away. You shouldn't do that all the time because that's going to make you break out more, but within that specific time, that's what you should probably go with, is just a cortisol injection. It's going to hurt, but it's going to get rid of at least that specific area at the time. And you know, some people will say, well, I want to get clear skin, but you know, a huge cyst development on my prom date, I'll give, you know, an extra, you know, a week or two more of bad skin just to have in that quick moment better skin for that photo shoot with your prom date or whatever. So, what are the genes conflicted by acne? So what are all the regulative factors that we need to look at when discussing acne from a genetic standpoint? All these. So some people want to find out what Accutane works on. Why is Accutane so effective? It's our most effective but also a fairly invasive treatment. Well, this is all of the genes that the researchers have found are afflicted by acne, and this is an illustration of them. As you can see, some of them. As you can see, there's a lot. In understanding the importance of each individual one of these is very difficult, but there are some ideas of which ones are more important than others. So, allergenicity. This goes into the idea that something
some antigens are more likely to be an allergen than others. This, I would say, is strongly variable from individual to individual, but there's certain characteristics that make certain proteins more likely to be allergenic than others. Why do people have a lot more soy, milk, egg, and wheat allergies than they do other things? It could be in part because they're much more strongly present in our diet, but it's also their chemical makeup as well. So one of the important factors when regarding allergies is penetration of barriers. So we have skin, gut, and lung that both keep things out of our bloodstream, out of the reaction area of the body. We don't really want things without first being sort of screened to come into the body. Obviously, we need proteins, we need fats and stuff so we can rebuild ourselves, but we need to sort of break those down and make sure those things are the most inactive as possible. So if you have, let's say, for a pinprick test, if you get a pinprick test for an allergy, if that pinprick is done too shallow or too deep, meaning if it goes too far below the skin, you're more likely to have an allergenic response. So you may be this is called the false positive. So if the deeper you give this pinprick, the more likely you are to have this response. And this is because you're bypassing the skin's the skin's reaction and going to an even more stronger response within the hypodermis, which is the deeper you get, the more reactive that you get, because it's a larger danger to the internal system. And that goes again with the gut. If things are just going, if you have an issue with your gut and have this quote-unquote leaky gut syndrome, you could potentially be at an increased risk of allergy development because your barrier is compromised. And now we'll go into level of antigen presentation. The best way to illustrate this is pollen counts. So some people aren't really allergic to things, but when the allergen count is ridiculously high, people who have never had an allergy attack are now getting stuffy noses, runny noses. They feel groggy, they feel tired, and this is because at some point you break tolerance threshold and you activate your immunological system. Each individual has different tolerances based on that whole slew of slides that I already talked about. But now that you've broken that tolerance level, you're at an increased risk for more intensive reactions following lower dosages in sense. So if you eat a tiny bit of, let's say, peanut, only a little bit is going to break through your gut barrier. But if you eat a lot of peanuts all at once, that's a huge antigen load, and as a result you could have an even higher response than you would have otherwise. And because if you get that excessive diffusion, you're more likely to get a change in your immune system to now respond aggressively to that with lesser dosages. Meaning that because this protein was once seen as this monstrosity that was basically trying to take over your body, it's like, well, no, I can't do that. We got to fight this thing. So basically, it's in the same idea that if you sit there and eat a jar of peanut butter, every day or something like that, you're going it's a lot more likely that you'll have you begin to develop a I shouldn't say a lot more likely, but it's more likely to have a development of an allergy response. So does that mean that it'll be existent forever? No, but once you get it, it's a lot harder to get rid of than if you've never had it. So it's important, I think, to diversify your diet and lower your antigen load, along with helping make sure that your barriers are fully intact. One thing that you could look at with lungs specifically and skin is if you're completely dehydrated, your skin is so frail and your cells are so I would say saggy that those barriers aren't great. They're a lot more leaky. If you rehydrate them, the cells plump up and they are a lot more apt to be able to fend off the antigen presentation. Along with, they work better. They simply work better when there's enough fluid to send chemicals through. If you don't have enough of this fluid, such as water, you're not going to be able to properly transmit areas, and things may become more isolated in your body. Meaning, if your skin can't send the right signals throughout the body that it's having an immunological reaction because it's too dried up, then maybe that's why your face isn't calming down, because you need more water. Does this mean that you need to drink 16 gallons a day? No. That's clearly not the issue if you're drinking that much water. What is the issue is if maybe you're drinking less than 2 liters of water a day, you could have some sort of effect of this nature. I'm not saying this is exactly how it works, but that's one frame of mind that you could use. Now, again, I said that some proteins have specific molecular compositions which predispose them. One of those molecular compositions, is disulfide bonds. Disulfide bonds are one of the strongest interactions that we have in biochemistry. These bonds are very, very strong. A lot of toxins use these bonds, and these are not well digested by your, or broken down, I should say, by enzymes. So this could be one of the reasons why eggs are at such a high risk of allergy development, because these bonds are so strong that you don't break them down into amino acids, these proteins into amino acids. These are much more whole proteins that are moving through your system, and they're much more likely to present epitopes. Remember, those are the things that your body actually makes antigens to, and therefore get an immune reaction. If all the proteins that go into your system were completely broke down into their most basic forms, like leucine, isoleucine, these are amino acids, broken down to amino acids, your body wouldn't respond to amino acids. Arguably, if it does respond to just these amino acids, then these are the building blocks to life. If you had an allergic reaction to these, you may be a much higher increased risk of just not being able to exist because you couldn't properly reform the proteins that you would need in your body. And that's why it could be that these disulfide bonds, which inhibit proper protein breakdown, could be at an increased risk of allergy development. The other thing is immune histocompatibility complex incompatibility, meaning that you're genetically predisposed to this allergen, meaning that you have the gene, that gene is being expressed, and your body is not liking it. So this may be the reason. This is one way that allergies can be passed down, and through this genetic predisposition. The other thing is that you have innate reactivity, meaning that, let's say again, you scratch something on a place on your skin, and then you place an allergy there. Well, now you're having a more intensive immunological reaction. You've also cut the barrier. So with all this reactivity, your body may say, hey, maybe the reason why we got scratched is because of this protein, or it's because we're having this response, it's because of this protein in the area. And so, because I've never seen it before, and so it sort of predisposes the condition for allergy development. Now, I really have to stress that individuals have a very high, they have a very binary approach, meaning if any one of these things isn't 100% accurate 100% of the time, then they're wrong. Which isn't really the case. These things are different for each individual, and we need to think of them within this complex notion, and also development. I mean, I'm trying to give you the information that's out there. It doesn't necessarily mean that all these things are 100% right, but what I want you to do is convince yourself of the direction that is right for you by researching it. And I'm giving you everything I can to give you the directions, all the possible directions that you could look at, while still trying to give you some focus. I'm not going to say, look, it's a huge friggin' problem, no idea how to solve it. I'm going to give you my take on how to solve these issues, and I believe you're getting to understand that. One of the most challenging things about allergies is not only their treatment, but it's their testing, defining whether or not you are actually allergic to something. This can be done through oral challenges. Basically, you consume a food product, and you're monitored. And this can be, you could monitor yourself in a 2-week period, and then you go report back to the doctor, or sometimes even longer than that, let's say a month, and then you report back to the doctor after you've started consuming that product and then eliminated that product, and see whether or not you've benefited from its removal from your diet. Now, then there's also, if you're anaphylactic to it, they also sit you under, if you presume you're anaphylactic to it, they sit you in a very controlled environment where you're monitored over the course of, I think, about an hour or so. Now, another way to do this, and someone would say safer, is that they just give you an allergic or an antigen injection into the skin, and then over the course of a 2-week period, that allergy is then looked at to see whether or not there's actually a reaction. So if your skin is reacting to it in a rash form, then it's deemed that you're actually allergic to it. Now, the interesting thing is that antihistamines usage before and after, if not during, along with antidepressant therapies, your circadian rhythm, so your sleep cycle, and with that probably melatonin as well, luteinizing hormone, estradiol, all these, and probably more, if not definitely more, have an effect on how this reaction occurs and the severity at which it occurs. So you may get a skin prick test, and then because you didn't get enough sleep, you actually have the reaction to it, or you don't have the reaction to it. Whereas if you've gotten a good night's sleep, you may not actually have a reaction, and your immune system may be intact in the sense that it knows what it wants to react to. So it's very challenging to say definitively whether or not you're actually allergic to something unless really you believe it to be true. Because the other aspect that isn't shown here is psychologically, you could induce an allergic reaction just from presuming that you're having an allergic reaction to it. So, and it's not to say that you can just think out being allergic to peanuts and having an allergic reaction or anaphylactic reaction to that and having your throat closed up and just think, oh no, I'm not allergic to you at all. There's grounds for this, but if you believe that you're allergic to any number of foods, you'll begin to display those symptoms. And so because of all these confounding factors, we need a better way of assessing whether or not someone is really allergic. I mean, and the other really important thing is that allergies are dynamic. So just because you were allergic to something one year doesn't necessarily mean you'll be allergic to it the next year. So, and just like something like poison ivy tolerance, that can go away after a certain period of time, and it can also go away if you're exposed to a high enough level of the oil. So this definition, defining something that's so dynamic, needs to go far and above what we're currently doing. I mean, especially if we're trying to get to a higher quality of life. You know, just telling you that, oh, you think you're allergic to peanuts, or oh, you think you're allergic to milk, you probably should avoid milk. That's really not what you're looking for. You're looking for a much more definitive answer. But for a definitive answer on a dynamic problem, you probably need a system in place that is as well dynamic. So something that can test and have a number of different checkpoints to define whether or not you're actually allergic to something. Something that's beyond the fact of, oh, your throat closed up because you ate peanuts. That probably means that you're allergic to peanuts, so you should avoid it. You know, we need something that can actually address all these intolerances, if you want to call them intolerances instead of allergens, that can cause rashes, that can cause gastrointestinal disruption, that can cause any number of things. So we need something that's dynamic, and there are some things in the mix that have had some limited success. So one attempt to create a dynamic system of allergy assessment is this thing called HemoCode. Now, HemoCode, what it does is it's both a survey and genetic testing to define what are your high-risk allergens. The unfortunate thing is that I wouldn't say that this science is in its infancy, and it isn't as clear cut as you want it to be. Meaning that you want something that is like 95% accuracy. You don't want to be thinking that steak is causing you severe lethargy and avoiding steak because you feel like it was going to make you more lethargic, unless it actually does. So one of the things that this also does is not only has a survey based on how much you consume of food products. So it guesses that if you consume a jar of peanuts a day, that you're overloading your immune system, and then that's a high risk food. So you should expand your dietary profile, and urges you to do so. The other thing is that it looks at past history and genetic markers to find out what sort of allergies are predominant for your genetic code. However, something like that isn't necessarily it's not going to be perfect. So if you were to try and address whether or not someone is allergic to something based on just family background and genetics, you wouldn't get actually the expression of those genetics. And that's what's really important, whether or not those genes are actually being expressed, and whether or not that intolerance is actually being activated. So, and you have decreasing likelihoods of, just because your mom was allergic to peanuts doesn't make you allergic to peanuts. And just because your genetic code suggests that you're allergic to peanuts does not make you allergic to peanuts. I mean, and I'll try and get some numbers for you, but and if I do, I'll display them. But I would say that the frequency at which those factors actually match up are less than 30%. So, and also keep in mind, it's what we're looking at too. I mean, even if 28% of the U.S. population is actually allergic or has an intolerance to something, that still leaves a great deal of people that aren't allergic that still have genetic heritages of allergies. So it can't be very accurate. I would say that at most, right currently, it's about 30% accurate going from just your genetic code. But with a dynamic system that they've also implemented, they may go beyond that. So you may have a 50-50 shot. This is all guesswork. But and they're suggesting that it takes the guesswork out of figuring out whether or not you actually have an allergen or something. And in my opinion, that's not necessarily true. There's still a lot of guessing to do, and it's very frustrating whenever you have something like acne in that it is so severe, and you're trying to find that cure-all. What the heck is causing my reaction? And is it a whole food group? Is that the cross-reactivity? What can I do, or what should I do definitively for 2 weeks, if not your life, to figure out whether or not or to figure out how you can cure yourself. So hopefully over time we'll be able to get this into a more refined state, possibly by adding other measures that we'll talk about in the next slide. These are two other attempts at defining whether or not someone is allergic to a food product or whether or not they're intolerant to it. One is the mediator release test. Basically, this quantifies, it says it quantifies dietary induced inflammation based on the lymphocyte changes. So whether or not something is actually breaking up or shrinking its volumetric size will tell you whether or not there's reactions occurring, whether or not that's excreting products. So with that, you can figure out supposedly if someone is allergic to something, taking, I believe, lymphocyte cells or blood tissue or blood cells and exposing them to those antigens, and then looking at these lymphocytes. So I mean, it's interesting that they're trying to do something like this. I just don't see the hit rate being something that would be on point with this, because there's so many things that can actually change lymphocyte volume. I think during testing you would have a lot of challenges controlling for that volume changes within lymphocytes. Now, the other one is actually using a comprehensive IgG food allergy test. So they look at whether or not you actually have a certain variety of IgG antibody, and then if you have that antibody, they suggest the chances at which you'll actually be allergic to it. So the other problem with this is very similar to the hemocode, in that just because you have something, and also the MRT, just because you have something doesn't mean you're actually that's actually directly correlated with it. So you could have elevations in IgG that don't mean you're actually allergic. So you could have IgG antibodies in your blood, and that doesn't mean that you're presenting with a pathological condition, let's say. So it doesn't mean that you're presenting with acne. It doesn't mean that you're presenting with difficulty breathings or lethargy, just because you have elevations of these antibodies. And figuring out what is the best correlative factor to define whether or not that antigen is actually causing a pathological condition is still yet to be found. Maybe the combination of all these together can solicit what exactly is occurring. And it's like I've said before, because this is a dynamic issue, it's impossible to say definitively what you're allergic to. And maybe there's certain and this is another aspect, is maybe there's certain times in a person's life which you can do testing and have it be more solidified. So if you test during adolescence, then you test during teenage years or after teenage years, and then you test midlife and then late life. You may actually have, let's say a 5-year span or 10-year span of which you're actually having a pathological condition to the exposures of these antigens. So you need to test yourself at those interims and controlling for drugs and medications as well, and testing after you've adjusted those variables. And as you can see, this gets rather complicated rather quickly. And I'll go back to MRT, and they say that the overall split correlation in this study was 93.6%, and the unacceptable correlation was 6.4%. So they suggest that these are very reliable ways of defining whether or not someone's allergic to something. I would love to review their study, or have somebody else do this exact same study. And if we can get something that has a 93% accuracy rate on whether or not someone's allergic to something, that's phenomenal. And if you only have 6.4% false positives, that's not too bad. I mean, and the other thing here is that there's not only a bunch of different foods, but there's a bunch of different things that people can be allergic to. So just because someone's not allergic to the main protein that most people are allergic to green beans at, doesn't mean that they're not allergic to some other variety of unique protein that's in green beans that is not being tested. So I mean, this is huge, and the MRT actually eliminates that that inability to define that specific antibody, because it's testing just for the volumetric changes. It doesn't matter whether or not you're allergic to one element of green bean or another. It just matters whether or not you're allergic to green beans in general. And so so then you could say, if it's just green beans, could you eat different varieties of green beans that would be okay, that don't have this level of this particular protein? It's miraculous that we have such a variety of food at our hands that we can't even figure out what we're even allergic to and what variety we are. So it's a very innovative time in the human timeline, and hopefully this will become, again, bring us around, hopefully this will become an exact science eventually. But currently I wouldn't rely upon these studies to define whether or not you're allergic to something. Kind of go by your feel, your comprehension of your body and what you typically react to, and the evidence that I've presented to you so far, along with your medical practitioner. Eczema and asthma could be tells for whether or not you're actually allergic to a food product, meaning that
because you have eczema or an asthma, you are more likely to actually have a food allergy, one that could affect your eczema and asthma, but also another aspect of your life, such as acne. So if you're like me, and whenever you consume milk, you actually have mild eczema on your elbows, and when you don't consume milk, you actually have a remission of that eczema and also a remission of your acne. That can be profound. So figuring out how many symptoms you actually have, and if you have been affected by asthma or eczema, could actually help you figure out whether or not you can find relief in your acne or these conditions through diet alterations. So this is really exciting evidence, and it's fairly recent. From my understanding, there was one study done on children specifically, and they were able to find some very interesting data on eczema and its atopic dermatitis. So we talked about reversing or growing out of an allergy. So small amounts of antigen are shown to be helpful in peanuts, milk, eggs, and other products. Now they have certain risks, and like I've told you, it has to be done in a controlled environment. These are some of the things that are occurring in a clinical experience that are showcasing certain changes within the mediation of an allergy and its presentation, and basically the allergen specific immunotherapy, giving small doses. How can you actually change these reactions? As you see here, you have an increase in IG1, IG4, and IgA, and you have a decrease of IgE. So all these are indicators generally of decreased allergen-specific proliferation. So all these are specific to the reduction of a allergic reaction. Now the interesting thing is that whenever you're talking about something like reversing allergen, that's different from something that is growing out of an allergen, because it seems that you can grow out of an allergen. Like I said, allergies are dynamic, but they're dynamic in not only the way that they can be turned on or turned off, but they're also dynamic in their presentation. So you may start off with, as an infant, you may start off with an allergy to milk, and that may give you eczema, but later on it may present with different types of atopic dermatitis. It may present with irritable bowel syndrome. It may present with asthma. So you think so in one sense you may think that you're actually cured of the ailment. So because let's say your eczema went away, you feel like you're cleared of your ailment, so you can drink milk. Yet you've noticed that there's an increase in your difficulty in breathing, but you don't correlate that, because it seems to be a harder thing to correlate something that is visual than something that is by feel. And you may think it's just I was born with this sort of condition, because you haven't really known your body long enough to figure out your breathing capacity, I suppose. So it's important to understand that just because you may feel that you've grown out of an allergy, trying to revisit those past allergies may be a way to address your current condition, and that being acne or any number of conditions. So to recap, the introduction to defense systems of the body. We've done non-specific resistances such as intact skin, mucous membranes, their secretions, normal microbiota. We've talked about the sort of second line of defense, which is white phagocytes.
Then we've talked about inflammation. We've talked about antimicrobial substances like the complement system, which can go in and attach to P. acne and sort of poke holes in it. We've talked about the third line of defense, which includes B cells, T cells, the superantigen that P. acne has that can cause hyperproliferation of the immune cells. And then we talked about antibodies and their ability to attach and block and basically adjust the immune system to food products and elements of the skin like P. acne. This should give you a good assessment of the role that the extensive role that the immune system plays in acne development. And if you kind of go back to something that I find very interesting in when you're talking about an intact skin, I find whenever I pluck my brow that I actually have a higher chance of having a papule develop specifically in that location of the plucked brow. So that can, and not much can be done to say with that degree of specificity where a papule will develop. I mean, there's just because you eat dairy, you can't say, oh, I'm definitely going to break out on my cheek or my forehead or my another location, let's say. I mean, there's some hormonal aspect in the chin and jawline, but I'm talking about within, let's say, 10 centimeters, on your brow. That's where I've found that I can actually get that degree of specificity with papule development. So the skin is certainly playing a role, along with the interior of the hair follicle, the hair shaft.